we have one question in the current homework assignment, homework 4B. 4B. Yeah. One question. And in the final, I like to give this question of this type in the final. Yeah. Later I'll talk about the question types a little bit for the final. Yeah. All right. The idea is very simple. First, we need to find the Fourier series. Then we just apply the Parseval's identity. Then we get a conclusion. That's simple. Yeah. All right. The first question. Use Fourier series of this function. Yeah. A simple function. Yeah. 2 pi periodic. Yeah. Then to show that this identity. Yeah. Here you can see if we do not apply the Parseval's identity, it is very hard to show this identity. Very hard. Yeah. All right. Now, let us find the Fourier series of this function first. Yeah. Yeah. First, we just apply the formulas. We calculate the Fourier series coefficients. Yeah. But this function, yeah, before you start your calculation, yeah, first thing you need to check even function or odd function. Yeah. Because in that way, you can make 1/2 of the coefficients 0. Yeah. Here it is an odd function. Yeah. Yeah, because at the left-hand side of the y-axis -1, the positive side 1, just the opposite. Yeah. Yeah. The sign opposite. Yeah. So that tells you it is an odd function. If it's an odd function, then we know all the cosine, all the coefficients for the cosine terms, all 0. Yeah. All right. So then we only need to calculate the coefficients of the sine terms. Yeah. All right. So we can write out the form of the Fourier series. We only have b coefficients. All the little a coefficients, all 0. Yeah. So let's calculate the b coefficients, yeah, by the formula. Yeah. For the odd function, the formula, yeah, we only need to calculate 1/2 of the interval. Yeah. But we need to double it. Yeah. There's 2, because the negative half the same. So we just double it. Yeah. Then let's do some simple calculation. We get this expression. Yeah. After that, yeah, then you need to write the coefficients explicitly. Yeah. Even, odd. When n is even, when n is odd, yeah. So the way to write it differently. Yeah. Even, odd. Yeah. So here, yeah. Right. Because look at that. When n is even, it's 0. When n is even, it's 0. When n is odd, 4 over pi times 1 over n. Yeah. So here you can see all the sign of even number of t, that coefficient's all 0, all gone. Yeah. So you only write the odd part. Yeah. All right. Then the last step, you can apply the Parseval's identity. So what's that? Let's review Parseval's identity. Yeah. This is Parseval's identity. Okay. Yeah. Right-hand side, square integral. Yeah. F squared. Yeah. Left-hand side, the sum of the squares of all the coefficients. Yeah. But for 0 coefficient, you need to multiply by 2. Yeah. All right. All a coefficients 0, so you only take the summation of the b square coefficients b terms. Yeah. All right. Then after simplification, after simplification, you get this identity. Yeah. Yeah. Pretty straightforward. Yeah. I hope. Yeah. So this Parsifal's identity, basically you just calculate the Fourier series. Yeah. After that, Parsifal's identity. Yeah. I hope. So everyone in this class, after you learn this topic, you should not lose the points on this question. Simple type. Okay? So this is simple type. Yeah. 10 questions in the final. 1/10. Yeah. So this one, if you make it, you get a 1/10 of the final points. Yeah. So that's very important. Yeah. So easy. Yeah, because when I did grading for some of the students, yeah, so I estimate so 1/2 of students did quite well, but the other half of the students, they missed many questions. They left many questions blank. Yeah. So there are several students, they left several questions, at least 2 or 3 questions blank. Yeah. You know, that's not good. Yeah. Yeah. And before the final, I will tell you all 10 question types. I hope when you study, do preparation. Prepare yourselves, you know, going through. Yeah. Because each question type, I give you, you have the sample examples. Yeah, from our homework or from in next week review session. Next week review session, I will do 2 review sessions next week. Yeah. If we do not have chance to practice in our homework, yeah, because the Fourier series, Fourier analysis, this topic, about 1/2, less than 1/2, less than 1/2. Yeah, we cannot practice. Yeah, yeah, because that's after the assignment of homework 4B. Yeah, so when I make the homework 4B question, we haven't covered those topics. Yeah, yeah, so I do not have chance. Yeah. Other than that, yeah, so you have the sample questions from our, 2 assignments. Assignment number 3, assignment number 4. Yeah. Matthew, you have a question? Or? No. Okay, yeah. All right, yeah. So later, after I finish this topic, I will talk about the question types a little bit. Yeah. First half, second half. Yeah. First 5 questions, second 5 questions. Yeah. All right, yeah. So I hope nobody missed this one. So simple. Yeah. Yeah. All right, let's see another example. Yeah. Actually, pretty straightforward. Yeah. So, but this time we have an even function. Yeah. 2π periodic. Yeah. So we need to show another identity. Yeah. So this time we need to calculate the Fourier series. Even function, so b terms are gone. So we only need to calculate a coefficients. Yeah. All right. A0, yeah. So, formula simple calculation. Yeah. And all the other a coefficients, simple calculation. Yeah. So then even, odd. Yeah. Look at the even, odd terms. Yeah. So then, here also you can see for n is an even number, all the coefficients are 0. Yeah. So we only have the odd coefficients. So we write the Fourier series in this simple way. Yeah. Yeah. And this question, actually, I don't think you need a lot of time. Yeah. If I give you the question of this type, yeah. So you should not spend too much time do the calculation. Yeah. The integral, not too hard to calculate. Yeah. All right. Then, the last step, apply the Parsifal's identity. Yeah. In the test paper, you do not need to copy. Oh, for yourself. Oh, yeah. So, because it's open book, open notes. Yeah. So you have book notes. You can look at the Parsifal's identity. Then you just, plug in, yeah, write the result. Yeah. So you do not need to write this identity on your test paper. Yeah, so we know you can find it easily. Yeah. All right. So open book, open notes, and you can use your computers, calculators, the computation tools. Yeah. But the limitation. Yeah. Here I say it again. Similar to our midterm, right? Similar to our midterm. So the limitation still, you cannot use search engine. You cannot use AI tools, okay? So you cannot use communication software. Yeah, that's the restrictions. Other than that, so no communication, you just look at your own materials, and you can use online calculators. Yeah. So it's online tools, but only for calculation. Yeah, for your Wolfram Alpha you can use. Yeah. And other similar computation tools similar to Wolfram Alpha you can also use. Yeah. So that's the basic requirements for the final. Oh, the classroom is different. Yeah. The classroom, I will post the classroom. Yeah. I will make sure. Yeah. Yeah, because I need to take a look at the classroom. I'm not familiar with the campus, so I need to go to the new classroom, not this room. Yeah. Same time. Yeah, same time. Yeah, from 6 to 8, 2 hours. Yeah. All right. Yeah. So any question about final, just let me know. Yeah, because we need to really prepare ourselves for the final. Yeah. These 2 weeks, this week and the next week. Yeah. All right. Yeah. Then plug in the coefficients. Then you do simplification, right? Yeah. So you will get the answer. Yeah. So that's simple. Okay. Yeah. So I try to, for every student, yeah, make sure. Yeah. So just like checklist. Okay. So 10 question types already explicit. So I give you explicit types. So make sure, can you solve all these types? Check one by one. Yeah. This one, I think everyone you can check it. Yeah. So easy. Yeah. Yeah. Simple calculation. Yeah. All right. Yeah. So we finish part D. Yeah. This topic. Yeah. Now let me move to part E. Yeah. All right. Part E, so many topics. Yeah. So the part D, part E, many discussion about the discrete Fourier transform. Discrete Fourier transform. I give you the concept questions. Yeah. So I may not give you the computation questions. Yeah. Discrete cosine. Yeah. Discrete discrete Fourier transforms. Yeah. Yeah, because the computation could be very time consuming. So I usually do not ask you to do too much. I try to control the computation complexity. Okay, not making too time consuming. Yeah, make it reasonable. So the discrete part, because in the real world situations, for the discrete part, most of the time you apply software. Yeah, because nobody will, you do not need to write your own programs to calculate it. Yeah, because a lot of software supports fast Fourier transform. Okay, yeah. So you don't worry about it. The reason I explain the theory, because you need a background to understand. Yeah. So why this algorithm is so fast? Yeah. Give you the solid background understanding. So that's the main purpose. Yeah. All right. Yeah. Let me go to the part E, fast Fourier transform topic. All right. Part E. Yeah, the review final. Yeah. So today, actually, I only talk about the topics a little bit. Yeah. So not, yeah. But I will not do the, going through the questions. Yeah. So let me give you my plan for 10 questions. Yeah. But next week I will give you explicit question types. Today I just give you, the general ideas a little bit. Yeah. All right. Yeah. Final exam. Ten questions. 10 computation. Oh, remember part B, right? Yeah. Part B. Part A, the quiz, online quiz style. Part A, 10 concept questions. 10, okay? Yeah, not like the 15 as the part A of homework assignment 4, number 4. Yeah. So 10 plus 10. So the total final, you have 10 plus 10 questions. 20 questions. Yeah. So reduced size, yeah, from our regular homework assignment types. Yeah. And remember, each question worth 4 points, but I give you 20 points free. 20 free points. Okay? Yeah, remember that. Yeah. Base points. Okay? So even if you do nothing, you have the 20 points. Yeah. Yeah. So starting from there, yeah, then, try to do as much as you can. Okay? All right? So now let me talk about today I give you the plan. Okay? Yeah. Next week I give you the specifics. Yeah. Details. All right. But based on the plan, you can study this weekend now already. Yeah. Yeah. All right. The coverage, we know coverage after midterm. Yeah, the topics, not comprehensive. Yeah, the new materials after the midterm. Okay. Yeah. Yeah. So the materials after the midterm. Yeah, because I want to save you preparation time. Okay? Yeah. Otherwise, too many questions. Right? Yeah. Even after midterm, we have many question types. Yeah. Yeah. All right. So then, after midterm, remember we have 2 assignments, right? Yeah. Homework assignment number 3. Yeah. So here, because computation questions, the B, part B. Yeah. And homework assignment question 4B. Yeah. Here you can see, yeah. For each assignment, 5 questions. 5 questions from 3B, 5 questions from 4B. Yeah. Things like that. Yeah. Okay? All right. So let's look at the 5 questions from 3B. Okay, all right. 3 topics I want to, give you these 5 questions to cover 3 topics. Yeah. All right. The first topic, linear systems of ODE. Okay, yeah. Linear systems of ODEs. Yeah, 2 questions. Yeah. Okay. So this one, 2 questions. Okay, all right. One computation question, one word question, word problem, one word question. Yeah. Okay, so one, equation question. Okay, yeah. Solve equation. Solve equation directed. And 1, 2, word problem. Okay? All right. Yeah. But for the equation question, remember, equation question. Yeah. All right. I may like to give you equation 3 by 3. 3 by 3 linear system. Okay, 3 by 3 linear system, not 2 by 2. Yeah. In our practice, we did 2 by 2. Yeah. 3 by 3, the same way, but you need to do a little more calculation. Yeah. But 3 by 3 in our review session, I will show you one example in review session. Okay, so you will see one example in review session. Review. Okay? Yeah. Session. Okay? Yeah. So let you see. Yeah. Yeah. Not hard. Not hard. Yeah. You calculate the, solve the characteristic equation, 3 eigenvalues. Then you can find the 3 eigenvectors, right? Yeah. So then, you do the solution. Yeah, yeah. So, all right. So that's the 2 questions. Yeah. The second topic. Laplace transform. Because Laplace transform, we have 1/2 of the topic we haven't practiced. Because in 3B, we have a few Laplace transform questions. So we have 1/2 topics we didn't practice in midterm. Yeah. So that part, that half is differentiation and integration. That topic we haven't practiced, tested at that time. So the also 2 questions. 2 questions. Okay? 2 questions, differentiation and integration. Okay? The 2 formulas, integration. Apply those 2 formulas to calculate Laplace transform and inverse Laplace transform. 2 questions. Okay? Yeah. Mainly use those two formulas. Okay? Based on those 2 formulas. Yeah. 2 questions. In review, I can give you 2 examples. Yeah. All right. Yeah. Review session. All right. So then the third topic. Third topic. Power series. Power series solutions of ODEs. 1 question. Okay? Power series. Solutions of ODEs. All right. We will do one example. Yeah, so in the review session, we will do one example. So then the final question, the same type, okay? Same type. Yeah. The type we will have different from our homework 3B question. Homework 3B, we have one question, but that one, remember we applied the Frobenius method. There are case 1, 2, 3. Yeah. That one we did case 1. Yeah. That one we did case 1. So I want to choose one question from case 2 or case 3. Yeah. Yeah. 2 or 3. Yeah. 2 or 3. So first I find appropriate example in the review session. Yeah. Review session. So case 2 or 3. Oh. Yeah. The lagging. 2, lagging a lot. 2 or 3. Yeah. 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 But I will look at the calculation, how hard it is. Yeah. So I try to make the question not too hard. So you can calculate, not very messy. Yeah. The purpose is, the calculation not too messy. Yeah. Case 12. So that from 3B you have these 5 questions. Yeah. All right. 4B, another 5 based on the Fourier analysis. Okay. Yeah. The topic related to the Fourier analysis. Yeah. Yeah. Here I do not give you the, today, this time, I do not give you the explicit 5 questions. Yeah. Yeah. But some information, I can give you some information. Yeah. I just mentioned that possible identity, that's 1. Okay? That question is 1. Yeah. There is another one. I can also give it to you, the question type, the possible identity. Yeah. That's 1. Another one, yeah. I need to give you an example in a review session. Then we do one similar question. That is, we need to practice the convolution property of Fourier transform. There is a convolution property. Okay? Yeah. So the convolution, apply the convolution theorem of the Fourier transform to solve an integral equation. Remember, in the Laplace transform topic, we did that, right? We apply convolution theorem to solve an integral equation. But I like to go, yeah, so Laplace, for that one, so we do not practice, okay? Yeah. So we practice Fourier transform version, yeah. Matthew?
So is that saying the linear system, both of those are going to be 3 by 3?
Yes, yeah, 3 by 3, yeah. I will show you a simple example in review session. Then I will control the calculation, not very complicated. The calculation you can handle, okay? Yeah, not very messy. Yeah, numbers, relatively simple, nice. Yeah, so, yeah, yeah. So, all right, 3 by 3. Yeah, all right. But the word problem 2 by 2. Okay, word problem, you need to solve linear system, but that one 2 by 2. Yeah. All right. Yeah. So the 2 questions from 4B. Yeah. So, yeah. Not necessarily from from the Fourier analysis. Yeah. Total 5 questions. This time I can give you 2. Okay. First one, possible identity. Second, apply the convolution theorem of Fourier transform to solve an integral equation. Yeah. All right? Yeah. So that's my thinking. Yeah. That's my thinking. Yeah. So in our review session, I will give you one such example. Okay? Yeah. Similar to the Laplace version, but we need to modify it. Yeah. The process, the whole detailed process, exactly like the Laplace transform, but we need to convert it to the Fourier transform version. Yeah. So that's the, yeah. 3 more, yeah. So now you have the 7 of the 10 explicit types already, right? Yeah. So 3 more to go. Yeah. 3 more, then I need to think about it. Okay. Yeah. So what are those last 3 questions in the Fourier topic? Yeah. Let me think about it. Yeah. Yeah. Because I want to, yeah. So definitely based on the homework 4B. Yeah. 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 So first I look at the homework 4B. So I want to select 3 question types from 4B. Yeah. 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 So that will be more reasonable. Yeah. Yeah. In this way, I hope when you do preparation, yeah, you'll go through all these 10 question types. You get yourselves familiar with all these 10 question types. Then do a good job. Okay? Yeah, because when I did a grading, I haven't done the midterm grading. Yeah, but I will do it soon. Yeah. So I want to see, because 1/2 of the students I worried a little bit. Yeah. So 1/2, yeah, they did a good job, so I do not worry about that half. But 1/2, they missed. Yeah, they missed several questions. Yeah, I hope these students, they can prepare well. After I give you 10 explicit question types, you have the sample questions, example sample. I hope you can prepare yourselves well for the final. Okay? Yeah. So that the other half. Yeah. So basically for the students, yeah, I just I complete the homework 2 assignment grading yesterday. Yeah. For those students who did not miss any question in the assignment, then so those students should be fine. Yeah. You didn't miss anyone. But for those students missed some of the questions, then you really need to, push a little harder, yeah, in your final exam preparation. Yeah. Yeah. So those students. Okay. No. Home assignment number 2. Yeah, midterm, I haven't started grading. Yeah. After I start grading, yeah, I will do comparison. Yeah. So if those students who missed some questions in assignment number 2, do they still miss questions in midterm? I want to see. Yeah. If they still miss some questions in midterm, yeah, it's a warning sign. Yeah. Yeah, but I noticed 4 or 5 students didn't submit. 4 or 5. Yeah, because homework number 2. Homework number 2. Midterm, a little better. So homework number 2, I got 10 students submitted. Currently we have 15. Yeah. 10 students submitted. Midterm, 12 students submitted. Yeah. So those students, no response. No, I didn't see any interaction. A few students, yeah, when I check the attendance, every activity, I didn't see anything. Several students, yeah. So that's something. Yeah, I may need to send them emails. Need to send, because if in that case, very likely they will fail the class. Yeah, they will fail the class. No chance to pass the class. Yeah. All right, let's move to our normal lecture. From signals to frequencies. Yeah. First, before I apply the fast Fourier transform, so let me set up the environment, prepare ourselves under the background setup for the main part of the work. Signal, remember last time I spent a lot of time explaining the discrete, how to represent a function with the discrete values. So in the real world application, most of the time we have discrete values. We do not have continuous function given. So what do we have? The discrete, the sampling values that we use to to find appropriate approximation function. That's the real world situation. Okay, all right, yeah. So now, based on that understanding, when we have a function, so here the function, you just understand as some imaginary function. Okay, yeah, because the real function nobody knows. The real function, it's just a concept. It is a concept. Yeah. So you cannot get a definition of a real function. Okay. Yeah. The real world data. Yeah. So what do you have? What do you get? A sequence of numbers. Yeah. A sequence of numbers. Yeah. So here we use a vector to represent the sequence of numbers given. So that is our real world data. Real world data. Okay? Yeah. Represented as a vector. Okay? Yeah. So if you want to see example, so the example I used last time, sound file. Okay? The music, the sound file, image file, and a video file. Okay? Yeah. So when we do processing, we use a sequence of numbers, digital signals. Yeah. So here the signal, it's a digital signal, not an analog signal. Okay? Yeah. So here we're working on digital signals. Okay? Not analog signals. Yeah. All right? Yeah. Then we do apply our discrete Fourier transform here. Okay? All right. So here, what do? We apply discrete Fourier transform. Yeah, the definition given last time. One big matrix, right? So, yeah, we do matrix multiplication. One big matrix. So then the result, we get another vector. So we use this f hat vector. Yeah. So we call it frequency spectrum. because we go to the frequency domain from time domain or spatial domain, yeah, to frequency domain. Yeah. So the operation is just, yeah, so here, if I wrote explicitly, yeah, the operation is this matrix multiplication. Okay? Matrix multiplication. Yeah. All right. That Fn matrix, it's a big matrix. So this F, capital Fn, it is a n by n matrix, square matrix. And that matrix, you know, the definition we saw last time. Okay? Yeah. So we can write that express matrix out, you know, all the entries. Yeah. So we have that matrix. Yeah. But here, in your mind, yeah, because in our real world applications, usually this n number is very large. Very large number in our real world applications. Yeah. 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 So then you can see a matrix multiplication n by n. This n is a very large number, but the matrix size n by n, you can see the computation cost is pretty high. Yeah. So then there is a question: how to make the computation faster? Yeah. Because when you do the Fourier transform in a typical application problem, it's not just once. Usually you need to apply this discrete Fourier transform many times, you know, hundreds of, even thousands of times. Yeah, because you know you need to do the processing again and again. Okay? Yeah. So very fast. Yeah. So many times. But look, if each time it takes your algorithm relatively slow, then the real world performance will be very slow. Yeah. So you don't want to see that. Yeah. So you want to get the fastest possible performance for your real world applications. Yeah. So for that reason, for this part E, we need to look at how to make the discrete Fourier transform as fast as possible. Yeah. So this fast Fourier transform. Yeah. So there is a smart idea. Yeah. So that takes advantage of the special structure of the Fourier matrix. That capital Fn, we call it the Fourier matrix. This Fourier matrix has some special structure. Yeah. It's not a random matrix. Yeah. If it's a random matrix, then we cannot. Because if the structure has no good properties, then we have to do the normal multiplications. We cannot take advantage of any special properties. Fortunately, our Fourier matrix have very nice, yeah, excellent structure properties. Yeah. Yeah. So we should take advantage of the special properties of the Fourier matrix. Okay? Yeah. Yeah. Then we can improve the computation a lot. Yeah. All right, so that's the, what we are going to do. Yeah. Then, in order to apply the Fourier matrix operation, yeah, so the basic notation we used in the Fourier matrix is this Wn. Yeah. That's e to the negative 2 pi I over n. Yeah. That complex number. It's a complex number. Yeah. So here we need to do the calculation in complex numbers. Yeah. All right? Yeah? Yeah. 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 So that's important. Okay? That's important. We cannot avoid, in this situation, we cannot avoid complex numbers. Yeah. Actually, in this situation, complex numbers give us, much better description of the real world. We need complex numbers, okay? The real world, yeah. Description, yeah. All right, yeah. So then, we only need this Wn number. Then we just take the certain degree, the power of this number. Then we can get all the entries of the Fourier matrix. Yeah. Okay. So that's simple. Yeah. So Fn basically, so the entry. Yeah. Two parameters, n parameter, k parameter. Okay. Yeah. And so the number of rows, number of columns. So two parameters. Yeah. Row n, row index n, column index k. Yeah. Yeah. So you use those two numbers, you can get the entry at the, because when we use the row index, we count from 0. Okay. And start from 0, 1, 2, 3 to n minus 1. Yeah. 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 So here you can see, yeah, I need to erase. Yeah. nk, yeah, starting from, yeah, these numbers. Yeah. All right. So that components, yeah, because we need to calculate each component here, okay? Yeah, each Fourier coefficient, each component. Yeah. Each component, it is a summation. That's the summation form. Okay. Yeah. Yeah. Here you can see n multiplications, right? Yeah. So, yeah. Sampling values, these f. So they are given sampling values. Then you multiply that, e, yeah, e term, e, that. So then you do the summation. Yeah. Each component. And you need to calculate n components, right? Yeah. N components. Yeah. That's just the one. Yeah. All right. So then, all right. Before we move to the computation details, I need to give you some basic concepts. Yeah. Resolution concept. Resolution of 2 pi periodic function f of, because for this function, we take sampling values, right? Yeah. Sampling values. Sampling values. Yeah. Yeah. Okay. All right. When you take sampling values, then how many sampling values do you take in each interval? Right? Yeah. 2 pi periodic in one period interval. Yeah. So that number related to the resolution concept. Yeah. All right. So here, the resolution is the smallest non-zero distance between adjacent values. Yeah. Remember, last class, we made assumption when we do the sampling of the, for a function, yeah, we do the equal space sampling. Okay? Yeah? Yeah. So then, what's the resolution? Yeah. Smallest distance. Yeah, because the, the distance between two other JSON samples the same. Everywhere it is the same. So that's our resolution definition. Okay? Yeah. Aliasing, another concept, aliasing. Yeah. Yeah, because in real world, our experience, based on our real world experience, many times we observe some weird phenomenon, yeah, some negative phenomenon, yeah, something we feel not quite right. Okay, yeah. So that's something related to this aliasing problem. Yeah, what's that? The misidentification of a signal frequency introducing distortion or error. Misidentification. Yeah. Because when your resolution is not a very small, yeah, the sampling values you take in a given interval, not many enough. Yeah. Not many enough. Okay? Yeah. Too little. Yeah. The number. Yeah. In that situation, then when you do the processing, you may have the misidentification problem. Yeah? Because your estimate could be wrong, right? So your calculation, yeah, not good enough, then you see the distortion things. Yeah. Because your calculation is, different from the location you calculated is different from the real location, right? So that's the problem. Different from a real location. Yeah, the error. So your error is relatively large. So you calculate the wrong location. Yeah. So that problem, the aliasing problem. Example. Yeah. In a motion picture, rotating wheels appear as rotating too slowly or even in the wrong sense, negative direction, right? You see, sometimes, in some video rotating supposed to be this direction, but you see opposite direction. Yeah. Opposite direction because the resolution is too low. Yeah. Too low. So then when you see, because the frame, right, on TV, in a video, sometimes the refreshing rate is too slow. Yeah. Refreshing, we know, each second, usually 30 frames each second, right? 30 frame, yeah, or 24 frames typically. Yeah. Yeah. The smallest 24 frames per second in a video. Yeah. So usually, 30 better, 24. Yeah. But if the rates smaller than that, then you can see a lot of aliasing problem. Yeah. Yeah. Something distorted. Yeah. Yeah. All right. Yeah. Right. Simply too few points. Yeah. So you need to make your resolution denser. Okay. Smaller. Yeah. More sampling points should be selected. Yeah. All right. Avoid aliasing by high resolution signals. No. Yeah, we get to the break soon. All right. So let's take a 10-minute break. So then after this slide, we will go to the computation part. Okay. So this slide just help us set up the environment. So then next topic, we will focus on how to make the computation faster. Yeah, I noticed my presentation computer has the lagging problem. Yeah, I tried to restart it. Hopefully next second half, when I do the handwriting, no lagging.